So for this case, this one becomes CO2 plus 2H2O plus 7.52 nitrogen. There is no excess air, there is no unburned fuel. Okay, now we take a look at some of the definition and terminologies that we use in combustion. Alright, okay, I believe you've seen the video on the theoretical combustion, right? Okay, first is a theoretical combustion where we assume, for theoretical combustion, we always put it as a 1 kilomole of fuel, right? So CH4, instead of there's a 2 kilomole of CH4, in order for you to get a theoretical combustion, you need to divide it into 2, so become 1 kilomole of fuel, CH4. And then you need to calculate the 100% theoretical air. Okay. And then after that, the product would be there's no unburned fuel or excess air, or perhaps excess oxygen. This must be just nice to produce the product, which is due to the chemical reaction of 1 kilomole of CH4 and the 100% theoretical air, right? So for this case, this one becomes CO2 plus 2H2O plus 7.52 nitrogen. There is no excess air, there is no unburned fuel. So that's actually the definition of a theoretical combustion. And suppose theoretical combustion also must be a complete combustion, but not necessarily complete combustion is actually a theoretical combustion, right? Okay, next we go to a definition which is represent incomplete combustion. If you look here, incomplete combustion is actually when you have a product with an unburned fuel. Okay, so instead of CO2 to CO2, H2O and nitrogen, there's another unburned fuel in your product, right? It's gonna have a CO, carbon monoxide, C, OH and H2. Alright, this is actually we call this as an incomplete combustion. Okay. Okay, next we talk about complete combustion. Alright, complete combustion when all combustible fuel is completely burned, right? For example, for this theoretical combustion, all of it is actually completely burned. All the fuel, CH4, is actually completely burned and produce a product. Okay, there is no unburned fuel, and they can have, but not necessarily have, excess oxygen or excess air, right? So that's how it goes for complete combustion. They can be completely combust and they can have excess oxygen. So for product, it's only excess oxygen, there is no excess air. Now we go to actual combustion. Alright, so basically actual combustion is other than theoretical combustion. Okay, if you have incomplete combustion in your problems, if you have a complete combustion with excess oxygen, so we call that as actual combustion. Even if you have a if you have a combustion with a 3 kilomole, for example, 3 kilomole of CH4, that one now not falls under theoretical combustion, now it falls under actual combustion, because we calculate for 3 kilomole of CH4. Perhaps that is the requirement of that system, right? So other than theoretical combustion, we call that as an actual combustion. Alright, now we go to the what we call as stoichiometric. Alright, stoichiometric is related to the amount of air, okay, supplied to the combustion process. So if you're before this we calculate for theoretical air, right? So that one is actually 100% stoichiometric, right? And then we have what we call as excess air. For excess air, for example, perhaps in the example put it something like this: 50% excess air, 200% excess air, meaning it's actually 150% stoichiometric, more 50% compared to the stoichiometric, so become 150% stoichiometric. So for the case of 200% excess air, it becomes 300% stoichiometric. And then during calculation, you can put it as 1.5 ATH or 3 ATH, right? And then this is starved air, not enough air, right, supplied for the combustion. So if starved air is 20%, meaning it's actually 80% stoichiometric. So for this case of 10%, so this one is obvious, become 90% stoichiometric. So during your balance equation, you can put it as 0.8 ATH and 0.9 ATH respectively for 20% starved air and 10% starved air. Okay. Alright, now we go to combustible and non-combustible fuel. Alright, not all fuel is combustible. Okay. For example, coal. Okay. For coal, this is the components, chemical components of coal. You have carbon, H2, O2, N2, NS, and then as well as ash, right? So for ash, here it's actually a non-combustible fuel, right? It's actually non-combustible. Ash is actually a non-combustible. So during your balance equation, the one that you need to consider only this carbon, H2, O2, N2, and S. Okay. So meaning we disregard the non-combustible. So if you have a problem, for example, coal, inside it is the chemical component. One of them is ash, and we assume as a non-combustible. All right. So we need to assume as a non-combustible for ash. So only C, H2, O2, N2, and S is combust with the air and produce the product. So the product is actually the product plus ash, right? Okay, so there are some of the definition and terminologies which I feel important for you to understand. Right, so that's all.